Hello, welcome to Haven of Excellence, where we get to interact, we get to solve mathematical questions, science questions. When I say science questions, I mean both chemistry and physics. Yes, so in this particular video, I just want us to talk about something on more concept. So this question came in one of the ECZ papers. I've just forgotten. Here it's written question 7, but I just got the exact question. I had to paste it there, but I prepared this for my learners, the people that I teach as part of their test. So let us get there. This question, it reads 4.00 grams of impure iron 3 oxide reacted with 600 centimeter cubed of 0.100 mole per decimeter cubed sulfuric acid. The first question says, construct the balanced chemical equation for the reaction. Okay, so one of the first things that we're supposed to know is we have impure iron 3 oxide. Okay, this is like a metal oxide reacting with an acid. So this is like an acid. It's like acid source and bases. So how then can we come up with an equation for this? They have said it. We know iron exists. It's a transition metal, so the valences may change. So this is a 3, which means we are dealing with iron 3. So I'll put my piece of paper where I'll be solving from here, so that you should see how this thing all goes. So we have iron. Iron is like that, positive 3, and oxygen, it's like that. We just want to come up with the formula there, of which we know that this should get there and the 3 gets there to give you iron 2 and 3, like that. They have said it that state symbols are not required, so you can just end it there. Then we have sulfuric acid. We know sulfuric acid, there are 3 common acids that they may happen to test you on. We have nitric acid. You just have to know the formula. Then we have sulfuric acid. You just have to know the formula. Then we also have hydrochloric acid. You just have to know the formula. These others, other substances you'll be given, you know how to do the crossing there. So now we are saying this iron 3 oxide reacted with sulfuric acid. Sulfuric acid looks like that to give us, we don't know what it gave us, but we are supposed to come up with the products. So always remember that it's like this is in a neutralization reaction. So which means we expect water to be formed, so it will be iron sulfate plus water. So this iron gets there, it becomes iron sulfate, but it will be iron 3 sulfate because we reacted with the 3 there. So the 3 on iron 3 will go on the sulfate there. So it will be iron 3 2 and plus water. But how did I get here? You should know that this is a radical which exists like that, and it's a radical, it exists like that. This is why you are seeing a 2 there. The crossing is the same thing, you do the same thing there. So now we need to balance. We have iron, the irons are 2 here, even there they are 2. Hydrogen, the hydrogens are 2 here, and here they are 2 as well. But the sulfate, there are 3 here. Sulfate, you need to multiply this by everything which is there. So the sulfates, there are 3 there, which means you have to put a 3 here in order to balance the equation. But when we do this, some elements will be affected, which means we are going to have hydrogen 3 times 2, which will give us 6. But here we only have 2, so we are going to put a 3 there, so that we should have 6 hydrogens. But again, oxygen will be affected here because oxygen will be like 3 Then here they are 12. So 3 plus 12, that will give us 15. So it means that, and here how many are there? We have 3 times 4, which is 12, then plus 3 is 15. So like this, it means it's balanced. It's balanced. So just by answering like this, it means you have gotten your 2 marks there. And that's how you get it. This is your 2 marks. The next question says, calculate the mass of the pure oxide that reacted with the acid. So we know that here we were given 4.00 grams. Then here we are given 600 centimeter cubed against 0.100 mole per decimeter cubed. So when we have a situation like this, mole per decimeter cubed, just know that this is concentration. Yeah, this is concentration. So they want us to find the mass of this oxide that reacted with sulfuric acid. We already have the mass, but this is the mass of impure. They want us to find the mass of the pure. So then we have to determine the number of moles of this sulfuric acid that reacted with this iron oxide. How do we calculate the number of moles? In this case, we are given a lead because we have the volume and the concentration. We have that formula to say number of moles equals to concentration times volume. So this volume has to be changed to decimeter cubed, which we know that 1000 centimeter cubed, it should give us 1 decimeter cubed. So 600 centimeter cubed equals to, we don't know. So we need to cross multiply there. We have 1000x equals to 600. Then you divide both sides by 1000, even here by 1000. And what you have is 0.123, 0.6, 123, yes, 0.6 decimeter cubed. So now we can go ahead to find the number of moles of sulfuric acid, which we are saying as number of moles equals to concentration. We are given to be 0.01 mole per decimeter cubed times 0.6 decimeter cubed. So this and that cancels. We have number of moles equals to, you multiply this times that, and what you get is 0.06 moles. So this is the number of moles that reacted with the sulfuric acid. Now we can use the mole ratio. We have a 3 there, we have a 1 here, an invisible 1. So to determine the number of moles of this oxide, 0.06. Here we don't know, we cross multiply, we have something that looks like this. Then we divide both sides by 3, even there by 3, and x gives us 0.02 moles. So this means that this is the number of moles that reacted, the number of moles that reacted of iron oxide that reacted with sulfuric acid. But then they want us to find the mass. So we can use the formula to say number of moles equals to mass divided by molar mass. But the molar mass of this, we need it. This one, oxygen is 16, then times 3, which will give us 1848. Then iron is 56 times 2, which will give us 2, 10, 11. So it's 10, 5, 6, 1. So it is 160 grams per mole. This is the molar mass of iron 3 oxide. So with that now, we can use it now. Going back here, it's mass equals to number of moles times the molar mass. So number of moles 0.02 times 160, which is the molar mass. And what you get there is, so this is the mass of pure substance that reacted with sulfuric acid. So we would have solved this question just like that. Yeah. Another question is calculate the percentage yield of iron 3 oxide, assuming that the impurities did not react with the acid. So I'll solve it from here. We know that percentage purity is given by actual yield over theoretical yield times 100, or mass of pure divided by mass of impure times 100. So the mass of a pure substance, we found it to be 3.2 grams divided by impure, we are given to be 4, so you put a 4 there, then times 100. What you have is 320 divided by 4, and 4 in 32, that gives us 8, and it's 80%, and that's how you get the answer, just like that. Thank you very much for watching. If you still need some help, I offer free tuitions, which is, you can get back to me on 0971 14 76 24 or 0968 14 22 90. These are my lines. You can get through to me on WhatsApp. Thank you very much for watching. I appreciate it. This is Haven of Excellence.